Imagine the entire sweeping, epic 13.8 billion year history compressed into a single, familiar week. This is not a trick, it is a tool. A way for our minds to grasp a timescale so immense it otherwise defies comprehension. When we say billion, the number is so large it becomes an abstraction. But a week? We understand a week. We live it. We feel its rhythm. By mapping cosmic history onto these 7 days, each day in this cosmic week represents nearly 2 billion years of actual time. Every hour is another 82 million years. Every single second that ticks by marks almost 23,000 years of cosmic evolution. This framework is our guide, our lens to see the big picture. Our cosmic week begins at midnight on Monday. In the very first fraction of a second, the event we call the Big Bang occurs. This is not an explosion in space, but an explosion of space. In less than a second, the universe undergoes exponential expansion, known as inflation, growing from subatomic in size to astronomical. The fundamental forces of nature, gravity, electromagnetism, strong nuclear force, weak nuclear force, separate and establish their identities. The universe is a searing, opaque soup of elementary particles, a roiling chaos of quarks and electrons, too hot for anything stable to form. As Monday progresses, it expands and cools. Minutes in, protons and neutrons form, then fuse into the first nuclei, mostly hydrogen and helium, with a tiny trace of lithium. Yet the cosmos remains a fog. Photons are trapped, constantly scattering off free electrons. Then, late on Monday evening, a critical threshold is crossed. Electrons are captured by nuclei, forming the first stable, neutral atoms. This is called recombination. Suddenly, the fog clears. Photons stream across space for the first time. This is the universe's first dawn. This ancient light, stretched over 13.8 billion years, is the cosmic microwave background, a faint, ghostly afterglow of creation. Tuesday morning arrives, and our cosmic week enters the cosmic dark ages. The first light has faded, and the first stars have not yet ignited. The universe is dark, cold, filled with neutral hydrogen and helium gas. Throughout Tuesday and into Wednesday, gravity is the silent, tireless architect, drawing matter towards slightly denser regions. Filaments of matter form a colossal, interconnected structure, the cosmic web, threads connecting dense, knot-like nodes. Gas streams into these gravitational sweet spots. Density and pressure rise until, by late Tuesday, conditions become extreme enough for the first stars to flicker into existence. Giants of almost pure hydrogen and helium, burning hot and living fast. Wednesday is the day of the first galaxies. Short-lived massive stars explode as supernovae, seeding carbon, oxygen, and iron. Enriched clouds collapse into new generations of stars. Infant galaxies feed along filaments and merge in a chaotic dance. By late Wednesday, the universe is lit by countless young galaxies. Their ultraviolet light reionizes hydrogen, ending the dark ages. The cosmic web is illuminated. The universe begins to look familiar, its framework woven by gravity, set ablaze by the first stars. As our cosmic week moves into Thursday, galaxy growth kicks into high gear. Vast clouds collapse, igniting billions of new stars. Inside their cores, fusion builds heavier elements. Stars create the diverse elements that will one day make planets and us possible. Stars are element factories. Smaller stars build carbon and oxygen. Massive stars forge up to iron, gold, platinum, uranium. Heavier elements form in supernovae and neutron star collisions. Thursday's fireworks scatter these elements across space, enriching the interstellar medium. Friday arrives. Our Milky Way takes on its familiar spiral form, a majestic city of over 100 billion suns. It grows by swallowing dwarf galaxies and accreting gas. Its spiral structure becomes well established. Around 8 to 9 billion years after the Big Bang, the disk is chemically enriched enough for our solar system to form. The frenzied growth calms. Star formation rates decline. Dark energy accelerates expansion. Big mergers wane. Our Milky Way settles into stability. The scene is set for a particular star and its family of planets. Saturday is a momentous day in our cosmic week. In a quiet spiral arm, a vast cloud collapses, perhaps nudged by a supernova shockwave. Nuclear fusion ignites. A new star is born, our sun. This happens around 4:30 in the afternoon. The surrounding disk flattens. Over hundreds of millions of years, about an hour on our cosmic clock, dust grains stick, pebbles form, rocks collide, planetesimals grow. Around 4:45, a young molten Earth forms. Shortly after, a Mars-sized impact throws debris into orbit. The Moon forms. Bombardment subsides. The planet cools. Water condenses into rain, forming oceans. By 6 or 7 in the evening, conditions are right. In warm, chemical-rich waters near hydrothermal vents, life begins, simple single-celled microbes. For the rest of the evening, life stays simple but transformative. Photosynthetic bacteria release oxygen. Over billions of years, oceans and atmosphere change. Around 10:30, multicellular life appears. Minutes later, the Cambrian explosion erupts with complex animals. By 1140, plants and animals colonize land. Just before 1150, dinosaurs appear and rule for 10 minutes. At 11:59 and 20 seconds, an asteroid wipes them out. Mammals now have their chance. We have arrived at Sunday, the final day of our cosmic week. For most of this day, Earth is dominated by mammals. Continents drift, mountains rise, ice ages come and go. Our story begins at the very end. Upright walking ancestors appear in Africa sometime after 11:59 p.m. on Saturday night. The entire evolution of the genus Homo unfolds in the final minute. Homo sapiens appears at about 11:59 p.m. and 57 seconds. Everything you've ever known as human history has happened in the last 3 seconds. Agriculture, pyramids, Rome, the Renaissance, the scientific revolution, blink and it's midnight. Our art, our music, our literature, our conflicts, our triumphs, iron in our blood, calcium in our bones. We are the universe's way of knowing itself.